Want a lucrative internship in the energy industry but don't know how to stand out? This is the video for you. I'm Mike from EE Bootcamp, and today we're breaking down a real, live posting for a role as a distribution asset planning engineer. I'll show you exactly how to decode the job description and tailor your application to beat the competition. Let's get your career started. So, just to give you some context, what you're looking at here is a real job posting. I used AI to rewrite it a bit and take out the company's name, but if you were to pop some of these details into a search engine, you'd probably find the original listing pretty easily. All right, let's break down what this job is all about. Essentially, this person is the strategic brain for the electrical distribution system. Their main goal is to make sure the grid has enough capacity for the future and to manage any risks that could cause problems. They do a whole bunch of planning and analysis to keep the lights on, all while supporting the company's bigger plan to modernize the grid. Their day-to-day work is super varied. They are the ones putting together the 5-year plan for the distribution network and even working with the transmission planning team on bigger, high-voltage projects. They act as a key link or a liaison between different groups like project management, design teams, and asset management. A big part of the job is also providing technical backup to the engineers in the field and the operations center. On the technical side, they're running what are called load flow analyses on a special system model to proactively spot potential issues, like if a circuit is going to be overloaded in a few years, and then they design projects to fix those issues before they even happen. They also meet with big commercial or industrial customers to figure out their power needs. Another critical part of the role is dealing with all the new solar farms and other distributed generation wanting to connect to the grid. This engineer is the technical expert who advises on how to make that happen safely and reliably. Oh, and this isn't just a 9-to-5 desk job. They're also the ones developing the emergency plans for when things go wrong, and when a big storm hits, they're on duty helping to lead the restoration efforts to get power back on for everyone. Basically, they work with just about every other team, from safety to operations to reliability, to keep the whole system running smoothly. So, a big part of this job is basically keeping a close eye on the entire electrical system. They're constantly monitoring and tracking the highest power demands on substations and circuits. Every year they run these detailed load flow analyses, which is like a forecast to predict how much electricity we'll need in the future for different parts of the grid. They also run other annual checkups, looking for potential overloads, voltage issues, and power factor problems, and they always study what would happen if a key piece of equipment failed. That's called a contingency study. Based on all that analysis, it's their job to actually design the solutions. They develop and propose specific projects to fix the problems they find, whether it's just from normal growing demand or for those what-if contingency scenarios. They also create and maintain all the emergency switching plans, which are the playbooks for how to reroute power when something goes wrong, and they provide that technical guidance to the design and operations teams. They don't just design the projects, they manage them too, using computer models and tracking loads to make sure the planned improvements are the best they can be. They're also the reviewer for new electrical system solutions, making sure everything meets customer needs, follows company rules, and most importantly, makes the whole grid more reliable. This means they're often in meetings with all sorts of people, from external customers and developers to government agencies, to explain standards and guidelines. And finally, when a major storm hits and the lights go out, they have a critical role in the response. They often start as a scout, going out to assess the damage firsthand, and then later in the restoration process, they shift to providing technical support or even helping lead the crews to get the power back on. Okay, so let's talk about what you need to qualify for this job. First off, you'll need a bachelor's degree in some kind of engineering. While they're open to mechanical, civil, or chemical, the clear favorite here is an electrical engineering degree. There's a little bit of wiggle room if you have a degree in engineering technology instead, but you'd really need to have your professional engineer license to make that work. In terms of experience, it's set up in a pretty standard tier system. You can come in fresh as an engineer straight out of school with 0 to 2 years of experience. From there, Engineer 2 needs 2+ years, Engineer 3 needs at least 4, and to be a senior engineer, you're looking at 6 or more years under your belt. But beyond the degrees and years, the person they're looking for has to be a real all-rounder. You need to have a solid, deep understanding of the engineering principles and the specific rules and procedures for the job. You've got to be the kind of person who makes smart, value-driven decisions and can even help mentor other engineers down the line. On the soft skills side, you need to be a good leader and a great communicator, both when you're talking to people and when you're writing things down. The job also demands excellent math and project management skills, and you have to be comfortable working with all the standard computer software. Oh, and you definitely need to know the National Electrical Safety Code and other rule books like the back of your hand. The role also calls for someone who can juggle a bunch of different tasks at once, handle high-pressure situations without cracking, and always make safety the top priority. You'll be dealing with the public, so you need to be pleasant and customer-focused, and you have to thrive in a diverse team. They also want someone with an eye for improvement, who can spot a way to make a process better and actually make it happen. One last really important thing: when a big storm hits and the power goes out, you're on the hook. This job requires you to be ready to respond to major outage events, which could mean being away from home for a significant amount of time, whether that's in your local area or sent somewhere else to help out. So let's talk about how you, as a student, can really set yourself up for this kind of role. Think of this job as the perfect mix of textbook engineering and the real-world hustle of keeping the lights on. The good news is, you're in a great position to build a foundation that will make companies want to hire you. The whole game plan is to make everything you're doing now, your classes, your projects, your networking, line up directly with what this job needs. First up, your classes. You want your transcript to basically scream, "I love power systems." Really lean into your core courses. In power system analysis, go all in on load flow studies and fault analysis. Don't just memorize the formulas, but really get what's happening behind them. Power electronics is huge for understanding the modern grid and how to connect solar and wind farms. And electrical machines is just fundamental for knowing how all the big equipment actually works. For your electives, be strategic. Grab anything on renewable energy integration, power system protection, or high voltage engineering. These are exactly the topics you'd be working with every day. Now, knowing the theory is one thing, but you've got to be able to use the tools. This is where you get your hands dirty with software. You should aim to become really comfortable with a major industry standard program like ETAP or CYMA. Don't just do homework problems on paper. Use that software for your assignments. Model a small power system and run a simulation to see what happens. Also, get familiar with a little bit of coding. Python is a superstar for automating boring tasks and crunching load data. And while you don't need to be a legal expert, you should get a feel for the National Electrical Safety Code, NESC. Just understand what it's for and the main rules it sets. This is the most important part, proving you can actually do the work. Your capstone or final year project is your golden ticket. Pick something super relevant, like studying the impact of electric car charging on the grid or figuring out the best place to put a new solar farm. And crucially, use that professional software like ETAP to do your analysis. Also, you absolutely need to get an internship, preferably with a utility company or a consulting firm. Even if it's not in planning specifically, the experience is invaluable for understanding how things really work and for making connections. Finally, it's not just about the tech skills. You need to develop the right mindset. This job is critical. When storms hit, people are counting on you. So seek out experiences that teach you how to work under pressure, like being on a competitive student engineering team. Practice explaining complex ideas in simple terms, because you'll be talking to everyone from engineers to customers to city officials. And definitely join a professional group like the IEEE Power and Energy Society. Go to their local meetings, meet people who are already doing the job, and just soak up all the industry gossip and trends. It's all about showing you're not just another graduate, you're someone who gets it and is already thinking like an engineer in this field. When you get to the interview, the real trick is to connect the dots for them. Don't just list what you did in school. Show them how it directly relates to the problems they need you to solve. You want to take your projects and experiences and frame them using the same language from the job description. So, for example, you could say something like, "In my capstone project, where I modeled the impact of EV charging on the grid, I didn't just run a simple analysis. I specifically performed annual overload and N1 contingency studies to find weak points in the system. I know that's a core part of this role, and my project gave me hands-on experience with that exact kind of proactive planning." Or, if you had an internship, you could explain, "My time at my previous company was huge for understanding how a utility really works. I learned how to read distribution design drawings, but more importantly, I saw how critical clear communication is between the planning engineers and the operations team in the field. I see that liaison responsibility as a key part of this job, and I already understand that dynamic." Even your technical skills can be framed this way. You could tell them, "For my thesis, I used Python to automate a bunch of boring data analysis for load profiles. It saved me a ton of time, and it shows that I have the skills to help your team monitor and maintain those peak load records much more efficiently." If you can do this, you're completely changing how they see you. You're not just another electrical engineering graduate looking for any job. You're someone who has been strategically preparing for this specific job. You become the candidate who already speaks their language and has a demonstrable passion for the work they do every day.